welcome back to the series on properties of geometric figures, and in this video we're going to do some revision around quadrilaterals. So we've looked at different types of angles, we've looked at angles and parallel lines, and now we're going to check out some quadrilaterals. Now, for disclosure, for this particular lesson I have actually adapted some Eddie Wu material for this lesson, so all credit goes to Eddie Wu. And let's get stuck in to some stuff with quadrilaterals. So what we're going to do today is we're going to look at the evolution of quadrilaterals, or what Eddie had described as the evolution of quadrilaterals. And we're going to use this diagram. Now, if you can follow along with this diagram, that would be fantastic. Now, to start with, we have just a straight up plain old quadrilateral. Now, quadrilateral is simply a four-sided shape. So I'm going to get out my ruler, because obviously you need a ruler to be able to do this stuff. And we're going to use a four-sided shape. So, what colour will I use? Let's use my trusty pink pen. So I'm going to move my ruler now, and I'm just going to create a shape that has four sides. That's it. Doesn't matter about anything else, it just has to have four sides. Okay, so there's my first quadrilateral. So all that this is, so I'm just going to label it, because it's not a special quadrilateral, it's just a regular quadrilateral. Okay, and its one and only property is that it has four sides. That's it. Done and dusted. That's a quadrilateral. Something with four sides. Now, we're going to follow these arrows, and these arrows are actually going to point us or give us an additional property to play with. So, the very first property I'm going to play with to get a new shape, I'm going to add a pair of parallel sides. Right, so I'm going to plus a pair of parallel sides, and I'm going to use our little two-stroke symbol for parallel. A pair of parallel sides. Now, what happens when we do that? We give our two parallel sides and we get a really funky shape. Now, hopefully you've been able to guess the shape. If you haven't been able to guess the shape we're making is a trapezium. And hopefully you're drawing just a little bit better than I am. And making good use of your ruler. Okay, so there's our trapezium. You might even find it referred to in some American material as a trapezoid, but here we're going to call it a trapezium. So we've got our trapezium. It's got two basic properties. It has four sides, two of which parallel. So to signify that they are parallel, we pop in our little arrows, the arrows to display that they're parallel. Now down the bottom we're going to add a different property entirely, and down the bottom the property we're going to add is pairs of equal sides. Alright, so we're going to add 2 pairs of equal sides. Now, what that does is that's going to give us a pair at the top that are equal and a pair at the bottom that are equal, and that's going to give us an entirely new shape. So a bit different to our trapezium. It's going to be a fairly rough drawing. And then I'm going to put the pair at the bottom. Get the ruler in the position. I'm going to pop this pair at the bottom. Okay, now to signify that these guys are the same length, I'm going to put a line on each of those and then 2 on there. So the 2 at the top are the same length, the 2 at the bottom are as well the same length. Let's fix up those ones at the bottom though. Because they're not looking as good. Okay, so those little dashes signify lines that are the same length. Now, if you're wondering what kind of a shape this one is, well, this is our kite. It can be referred to as a diamond, but tends to be called a kite. We also have another shape that sometimes gets called a diamond as well, but we'll get there. Now you can see that these 2 shapes now come into the middle to create another shape, another special shape. There's going to have all of those properties combined. All right, it's going to have 4 sides, 2 pairs of parallel sides, and it's even going to have pairs of equal sides. But the equal sides now are going to be opposite. So coming up from our kite, we're going to have 2 pairs of opposite, or the 2 pairs of opposite sides are equal. Okay, so we've got those sides that are equal. And then over here, our 2 pairs of opposite sides are parallel. Let's squeeze that in. Okay, so the shape we're getting now is, you guessed it, a parallelogram. So let's whack a parallelogram in. And again, hopefully you're drawing slightly better than I am. Alright, might even get the eraser going. Get the right eraser going. Just to tidy that up a little bit. Alright, so now we have our parallelogram. And we need to signify that these 2 lines are parallel. Now, the opposite ones are also parallel, so we need a slightly different symbol. So we're going to use 2 arrows instead of 1. And then we need to say that they're the same length. So 1 dash for each of those, and then the double dash for those 2. So now we have our parallelogram. And to spell that, we just use the word parallel and then ogram on the end of it. Now, we're going to forge ahead. And now we're going to split off into some more properties. And across the top there, we're going to bring in now some angle issues. And the angle that we're going to bring in is a 90-degree angle. So we're going to add one 90-degree angle. Now what that does is if you have some 4, say, paddle pop sticks and you've set them up in a way that they look like a parallelogram, if you make one of those angles a 90-degree angle, what happens naturally is that all of the sides, all of the angles now become parallel, or not parallel, 90 degrees. So just as an added bonus, when we get one 90-degree angle in our parallelogram, we actually now have 4 90-degree angles in our parallelogram. And that gives us a whole new shape, which is really cool. And that's the rectangle. So we're drawing out a rectangle. Now you guys might be wondering, hang on, why aren't we at the square yet? Well, we're getting there. I promise we'll get there. So now we have our rectangle. Could have drawn that a little bit better. Okay, so now we have our 90-degree angle that we were talking about before. We still have these babies parallel and equal. And we have the other ones parallel and equal. Okay, so we've gone from just having a straight up 4-sided shape. We've added pairs of parallel lines. We've added equal sides, pairs of equal sides. We've made those equal sides opposite to each other so that the opposite sides are also parallel. We've now added some 90-degree angles to get to our rectangle. Okay, now you can see that there's an arrow at the bottom, because what we're going to do down the bottom, we're not adding an angle down the bottom, we're going to add all, if I get the pen to work right, all sides equal. Okay, so all sides are equal. I might just write the word equal there, might just be easier. Okay, so now that we've got all sides equal and parallel, we have a really, really cool shape. That if I get this right, will look exactly what we want it to look like. Now let's make sure we get this right. And that's almost a perfect drawing. A little bit wonky at the top there. But what we've got now is a different type of shape. We've still got the sides that are parallel. Okay, but this time we also have all 4 of those sides are actually equal. So we just need one little dash on all of those sides. And what we've got now is this special shape called a rhombus. So that one's a rhombus. Okay. That all leads us to our very last shape. Our very last shape in this bit is all of those properties put together. So it's got the four sides. It's got pairs of sides that are parallel. It's got pairs of sides that are equal. In fact, all of the sides are equal. It's got the 90 degrees, which means all of the sides are 90 degrees. So all 90-degree angles, all sides are equal, all sides or pairs of sides are parallel. We have finally made it to that very, very special quadrilateral known as a square. So let's draw in our square. Make sure we try and get it right. And then I can actually get rid of, I actually can't get rid of the rule yet. Alright, so it's a little bit of a wonky drawing there, but essentially this is what we've got. We've got our 90-degree angle. We have all of our sides are equal, and our opposite sides are parallel to each other. And it's got all of the properties that the other ones do, and it is now a square. Okay, we've got one last little thing to talk about in terms of these shapes. So 3 of these shapes actually have a very similar feature to them in terms of the diagonals. So let's have a look at our shapes. So if we look at our kite, alright, we'll look at the kite and we draw in some diagonals. We can see that these diagonals if it's drawn properly are supposed to meet at 90 degrees and one bisects the other. Okay, so our diagonals here meet at 90 degrees. Alright, and one bisects the other, meaning that these two sides, or these two parts of the diagonal, should be the same size. So I'll put some extra dashes in there. Okay, so one bisects the other. Now, the gold thing about this one is that similarly, that happens with the rhombus. Okay, so with our rhombus, we have our diagonals, and we have our other diagonals, and what we've got here is these guys meet at 90 degrees as well, but they bisect each other. So this side is the same as that side, and that side is the same as that one. So now we have our diagonals they meet at 90 degrees still. Okay, they still meet at 90 degrees. but now they bisect each other. Okay, and I'll just fix up some of my writing there. Just to make that look a little bit better. There we go. So that's what's happening with our diagonals. Now, those diagonals transfer into the square, but now we've got just one little extra bit there, that not only do they meet at 90 degrees and bisect each other, they are all now exactly the same size. So let's pop them in. There's one. There's our other one. We meet there at 90 degrees, but these guys are all now the same length. Okay. So our diagonals. Okay, so our diagonals meet at 90 degrees. They bisect each other. And they are all the same length. Or they are all equal. Probably would have been easy to write. Okay, that's it for this particular video. Please tune into the next one so that we can have a look at some more properties of these quadrilaterals that we're dealing with. Just to make sure that we're on top of it, and then we'll get into some examples. Thanks for watching.